Hello and welcome. If you've ever heard a developer sigh and say, but it worked on my machine, then you're already halfway to understanding the problem that Docker was created to solve. Today, we're going to pull back the curtain on Docker and really dig into why this technology is such a massive game changer, especially when you compare it to old-school virtual machines. So here's our game plan. We'll start with that classic developer headache, then we'll introduce Docker as the hero of the story. We're going to look under the hood to see how it all works, put it head-to-head with virtual machines, and then we'll look at why this is all pointing towards a future built on containers.
All right, first up, the deployment dilemma. Let's talk about a problem that has caused, well, let's just say a lot of stress and late nights for developers for a very, very long time.
This is the million-dollar question, isn't it? An application isn't just the code. No, it's the code plus all of its friends, the dependencies, the libraries, the specific configuration files. So when you move your app from a developer's laptop to a testing server and then to the live production server, any tiny difference in those environments can make the whole thing just fall apart. That's the deployment dilemma.
And that brings us right to our next section. Because to solve this mess, a new hero had to step up. And back in 2013, this open-source platform called Docker showed up and offered a just brilliantly simple solution to this super complex problem.
So what is Docker at its heart? It's a tool for packing up your application and everything it needs to run into one single neat standardized package, a container. Think about a shipping container in the real world. It doesn't matter if you're shipping bananas or car parts, the container is a standard size and any crane or ship can handle it. Docker does that exact same thing, but for software.
And this quote just nails it. A Docker container bundles up the app, its libraries, its configurations, the whole shebang. You build that package one time, and it will run the exact same way on your laptop, on a test server, in the cloud, anywhere. That whole "it worked on my machine" problem, gone. Just like that. Okay, so that sounds fantastic, right? But how does it actually work? Let's jump into our third section here and see how Docker takes a plain old text file and turns it into one of these super powerful portable containers. And you'll see the process is actually surprisingly simple.
It all kicks off with a simple text file called a Docker file. Seriously, it's just a recipe, a list of steps. Start with this operating system, copy my code in, install these specific things, and so on. Then you run a command to build a Docker image from that file. Think of the image as a read-only template, like a perfect snapshot of your app. And finally, you tell Docker to run that image and poof, it spins up a live, running, totally isolated instance. And that's your container.
And now we get to the main event. You might be sitting there thinking, hang on a second, packaging an app to run in its own little world? That sounds an awful lot like a virtual machine. And you know what? You're not wrong. The goal is similar, but the way they do it is completely different. And that difference, well, it changes everything.
Okay, now this slide is so interesting because of what you don't see on the Docker side. Look at the left. With virtual machines, each application needs its own complete guest operating system, a full copy of Windows or Linux. It's kind of like building a whole separate house with its own plumbing and electricity for every single guest you have over. But now look at the Docker side. The containers are sitting right on top of the host's operating system, sharing its core, its kernel. There's no heavy guest OS. It's way, way more efficient.
So here's the bottom line. Virtual machines virtualize the actual hardware. They create an entire fake computer for each app. Docker, on the other hand, virtualizes the operating system. And because it shares the host OS and only packs in what's absolutely necessary, containers end up being incredibly lightweight and ridiculously fast.
Now for Section 5. Let's see how that big architectural difference leads to some frankly staggering real-world advantages in performance and efficiency. This is exactly why Docker just took the world by storm.
I mean, just look at this. Look at the boot times. A virtual machine has to fire up an entire operating system from scratch. That can take minutes. A Docker container? It's just starting another process on an OS that's already running. We're not talking seconds here. We're talking milliseconds. The difference is just night and day. And this speed advantage isn't just about startup. Because containers talk directly to the host's core without a bulky translation layer called a hypervisor in the middle, the performance is almost the same as if it were running natively. This chart here shows it plain as day. For things like accessing the disk, Docker just blows this common type of VM out of the water. And this efficiency creates this massive ripple effect. Because each container is so small and light, you can pack way more of them onto a single server compared to those bulky virtual machines.
You're just not wasting precious resources running dozens of duplicate operating systems. And that means lower hardware costs and a much easier way to scale your applications when you get busy.
So let's just recap the big wins here. You get unbelievable speed. You get true portability. Build it once, run it absolutely anywhere. You get higher density, so you can run more stuff on less hardware, which saves money. It's just a more efficient, more scalable, and frankly, a more modern way to build and run software.
So where does that leave us? Well, that brings us to our final section, the containerized future. Docker did a brilliant job of solving how to run one application. But what happens when modern apps are made of hundreds or even thousands of these containers all trying to work together?
Yeah, trying to manage all of that by hand is, well, it's pretty much impossible. It would be chaos. And that chaos led to the rise of something called container orchestration. Tools like Kubernetes came along. It acts like an air traffic controller for all your containers, and it automates the deployment, scaling, and management of these huge, complex applications.
So, the really big takeaway here is this. By solving that fundamental, it works on my machine problem, Docker didn't just make a better version of a virtual machine. No way. It completely changed how we think about building, shipping, and running software. It paved the way for the massive, scalable, cloud-native apps that power pretty much everything today. And that leaves us with one final, exciting question. Now that we have this foundation, what new possibilities will it unlock next? Thanks for watching.